This video is all about using the addition formulae. I'll post a link in the description to a video where I have derived all of these formulae that I'm going to show you. So I'm not going to go through the proofs in this video, I'm just going to show you what the formulae are and then how to use them. The point of these formulae is that we can't expand trigonometric brackets in a most obvious simple way that you might think we can. Sine of a plus b is not the same thing as sine a plus sine b. We can prove that with a very simple example. If I said sine of 30 plus 60, now we know that 30 plus 60 is 90, and we know that sine 90 is 1. However, if I was to do sine of 30 plus sine of 60 separately, I know sine of 30 is 1/2. I know sine of 60 is root 3 over 2. And clearly, 1 plus root, clearly we can see these things are not the same. So the question then is, well, what does sine a plus b equal if it doesn't equal this? These are the trigonometric identities. They are given to you in the formula sheet. You don't need to remember them, but having said that, you are going to use them so much over the coming weeks that you will eventually learn them. There are 6 formulae here. There are 2 in each of these. There's 2 formulae here, 2 formulae here, 2 formulae here. So it says sine of a plus b is equal to sine a cos b plus cos a sine b. Alternatively, if it was a minus, it would be sine a minus b would be equal to sine a cos b minus cos a sine b. So basically all I'm saying here is that if you have a plus here, then you must have a plus here. If you have a minus here, then you must have a minus here. And that's the same with the cos formula. If we have a plus here, now notice the difference here, there has to be a minus. So with cos, it actually flips. If it's a plus, it has to be a minus in the middle. If it's a minus in the middle, then it has to be a plus here. With tan, if it's an a plus b, then it would be a tan a plus b, and it would be a 1 minus tan a tan b. If it was tan a minus b, then it would be tan a minus tan b, all divided by 1 plus tan a tan b. So those are the 6 different addition formulae. Like I say, I'll post a link to the video where I actually prove where those things come from and show you that they are definitely true. But let's have a look at a few examples where we're actually using them. So here, I want to use the compound angle formulae, another name for these, to expand this expression. So I can write down, using the formulae, sine theta cos 45. So this is my sine a cos b, minus, because it's a minus in the middle here, cos theta sine 45. This is my cos b sine a. And I can actually simplify this a little bit further because I do know what cos 45 and sine 45 are. In fact, they're both root 2 over 2. So I can simplify this further and say sine theta times root 2 over 2 minus cos theta times root 2 over 2, which in this case I could simplify a little bit more to factorise the root 2 over 2 outside and just leave me with this if I wanted to. So this is the same thing as this. Here, I'm asked to prove that tan A plus tan B is identical to sine A plus B all over cos A cos B. I'm going to start on the right-hand side because there's more things I can do over here. And I'm going to expand the numerator out. I'm going to expand the sine A plus B. I know that sine A plus B is equal to sine A cos B plus, because there's a plus in the middle, cos A sine B. So that's the numerator. I'm now going to divide all of that by the cos A cos B. Now, because I want to end up with two separate terms here, let me split this fraction up into two terms. I'm going to write sine A cos B divided by the cos A cos B plus the cos A sine B divided by, again, the cos A cos B. So that's me just splitting this single fraction up into two separate fractions. Now I notice that the cos b's here cancel out, and over here the cos a's cancel out, and also remember from year 12 that tan x is equal to sine x over cos x. So here when I have the sine A over cos A, I know that's equal to tan A, and over here I know the sine B over cos B is equal to tan B, which is the left-hand side. That's what I was trying to prove. Okay, two last examples rather. Here I'm asked to use the addition formulae to find the exact values of sine 75. In an exam, this would be it would say calculator methods are not allowed for this question. So we have to do this. We can't just type this into the calculator. No exam's ever going to ask you to do that. So calculator methods are not allowed. So sine 75, how could I do that? Now you need to remember that we should remember the exact values for sine 30, sine 45, and sine 60. You should remember them. You should remember that sine 30 is a half, sine 45 is root 2 over 2, and sine 60 is root 3 over 2. You should remember those. So, in terms of how I could use those to get sine 75, I can think of 75 as being 30 plus 45. Now I can use the addition formulae. I can write this out as being sine 30 cos 45 plus cos 30 sine 45. Now I'm going to use those exact values from memory. Sine 30, I remember that's a half. Cos 45, I remember that that's root 2 over 2. Cos 30, I remember that that's root 3 over 2. And sine 45, I remember that that's root 2 over 2. Simplifying this then, the half times root 2 over 2 is root 2 over 4. The root 3 over 2 times root 2 over 2 is root 6 over 4, which I could then write as just, because I've got a common denominator, like that. This is the exact value of sine 75. So that's how you can work something like this out without using your calculator. Tan 15, we'll do that quickly as well. It's going to need a bit more space to do this. So let's just do a quick screenshot. Okay, so tan 15. I can think of tan 15 as being tan 45 minus 30. So now I'm going to use the tan addition formula, and I can write this as being tan 45 minus tan 30, all divided by 1 plus tan 45 tan 30. Now I remember that tan 45 is 1. I remember that tan 30 is root 3 over 3. And I've got 1 plus tan 45 is 1 times tan 30 is root 3 over 3, which is going to simplify to be 1 minus root 3 over 3 over 1 plus root 3 over 3. To simplify this further, I would times top and bottom here by 3 to get rid of that awkward fraction. So that's going to give me 3 minus root 3. That awkward 3 there is gone, and that awkward 3 there will go as well. And at this stage, all I would do, I'm not going to do this because I'm running out of space, but all I would do now is rationalise the denominator, just like we did at GCSE, by timesing by 3 minus root 3. 3 minus root 3. And if you work all that through, you will get your exact value of tan 15 without using a calculator. So, like I say, I'll post a link to a video where I prove these things, but the most important thing is you copy these down and you get to know them and you get to know how to use them.